I'm Maria Ruano Najarro.
I'm Kevin Garcia King, and this is
Sounds Like Infrastructure. People could come to the conclusion that everything has already been invented, that we can give it endless thought, but we already have everything we need. Big mistake. In fact, the world is continually changing, and evolution is, well, never ending.
Many of these challenges are spurred on by challenges life throws at us, challenges that force us to rethink and find new solutions. Want to know how?
Let's visit 4 stops around the world to see how construction, architecture, and engineering keep evolving thanks to the daily efforts of hundreds of thousands of people. Our first stop, Peru.
The World Bank estimates that 30% of global work is done remotely. The COVID-19 pandemic led to a big increase in this way of working. But do you remember what it was like working from home during lockdown? The kids running around, delivery people knocking on your door at all hours, and those endless Zoom meetings.
This is what happened to David Azpiazu, project director at Ferrovial Construction. But with one added difficulty. Maybe working from home didn't particularly change your day-to-day, but being in charge of the construction of a control tower in Lima Airport, Peru, and not being able to go to the site, well, that's a problem. Or is it not?
At that moment, Acciones manager and I had to reinvent. Let's say we started to think that we had to start as manager to manage this project without living in the country. So that is a little bit difficult. So as well as how to monitor or follow up the construction, we also made decisions regarding how to manage all the team. So first of all, to monitor or to follow up the construction on site, without being in the country or living in the country. So first of all, we hired a company in Peru to see how we could monitor the works on the field without being there, the most accurate.
David was overseeing the operation from his home in the US, thousands of miles where the control tower was being built. Want to know how they did it?
With this company, we agreed that since this was a very vertical works, because it was a control tower, so since this control tower we had placed a tower crane to build up all the tower, we could put a couple of cameras in the tower crane. So this way we could check all the works of the control tower, from the foundation until the roof. As well as this project had other auxiliary, let's say they were called auxiliary buildings. So to monitor these auxiliary buildings, we also put several cameras all over the field. These cameras were located in order for us to check not only the auxiliary buildings, also the civil works, let's say piping, the excavations, and everything. With these cameras, we had placed more or less about 6 cameras. We could check the work site every 15 minutes. So every 15 minutes, we could check. There was it was a time lapse of 15 minutes. As well as this, we also made a decision of using the drones. Let's say on a weekly basis, we were going to fly over the work site, a drone, where we could take all the pictures of the situation at that moment of all the works.
This way of working in construction isn't common, not now and not then. But the pandemic changed the rule book. It taught us the true meaning of resilience and forced us to work in new ways.
It has been a challenge for me because, as I said, or I told you before, I was very far away. You cannot touch, you cannot feel closely what you are building or making. So thanks to these technologies, to these drones, cameras, and all these things, sometimes I could feel as I was there, close to them and pushing or moving forward with the team. So for me, I think it has been, maybe the most important challenge in my career. Yeah.
So far and yet so close. It was a really challenging moment in time, but innovation and technology helped bring people together.
Technology helped me to meet people that at this moment I've never met in person. So at the end, I felt my coworkers as part of my life. We had knowing them on the Peruvians, the other Spaniards that were working with me from the young venture. It was for me this project. I will never forget it. And at the end, you feel weird, but you feel that you have been working with these people for years, as they were sitting here close to me.
Let's continue our journey. Next up, Texas. Imagine having a project that you're about to deliver when someone in the team suggests, let's start from scratch. Well, almost.
We had to build a bridge that it had some new characteristics. So that bridge, the edges had some aesthetics and some curve. It was a signature bridge when it was called. That requires some special methods of construction. When we were with the design, so okay, how are we going to approach this construction for the edges, because those were very special pieces. The initial idea was to build the pieces on top of the central part of the bridge. When we were doing some calculations, we identified that wasn't possible. So when the idea was already developed like by 60%, we encountered that, okay, that's not going to pass. And we had to talk to all our stakeholders and cooperators, engineering services, from Weber, the Mamuet, the supplier for the heavy lifting operation. And we had to say, okay, this is not going to work. What can we do? All as a team, try to sit and get a new idea.
That's one of the advantages of working with a team, having trust in your colleagues. It was time to go back to the drawing board, facing all the immense challenges we talked about earlier. By the way, he's Jofra Obrador, area manager at Weber. He's going to be our guide at this stop in the US.
One of the superintendents from Mamuet just brought up an idea is why we don't use the SPMT. SPMT that allowed us to install those pieces within the traffic restrictions that we had. We were building those portions of the bridge in one of the major highways in Dallas, where the state only allowed us to work from 9 p.m. to 5 a.m. in the morning. That was a very tight window. So the fact of choosing a new system, it required to rebuild the design, so start from scratch the design, but at the same time, using that system, the installation of the 4 pieces could be done in just 2 weeks instead of several months. The previous system, it required almost 2 to 3 months for the installation. And now we went back to the system with SPMT. It was only done with 2 weeks. That's all the time we needed to complete the installation of these massive concrete pieces.
Finding solutions to challenges. SPMT, that's self-propelled modular transporter, an innovative system that they'd never used and was unknown in Texas. The SPMT helps to move any part of the construction anywhere. It's a bit like a giant shopping cart with wheels that you can move in any direction, even over itself. The possibilities are endless. And since you can control its movement almost to the millimeter, it greatly reduces mistakes.
So having done the choice of going with the SPMT, it was a hard choice to make. Actually, we had several meetings internally just to evaluate the cost analysis, the timeline, and the potential savings or the impact of going back to zero, right? SPMT really helped us on building something using new technologies, saving 3 months, despite that we spent some time on the design. At the end of the day, it was a more successful solution, more safe, and technically very rewarding for the entire team.
Thanks to the SPMT system, the team could manage the risks involved in moving the building materials for the bridge final construction and do it on time.
Working 7 days a week at very specific times of the day to avoid disrupting the road they were working on, it's a project they will never forget.
Participating in this project was really exciting for me. It's one of these projects that's once in a lifetime. I would like to repeat it. Working as a team in a very high-profile team with all the help of our engineering services in Weber, with Mamoe team, having a lot of stakeholders involved, even techs got involved. It was very rewarding. I definitely would like to repeat something like that in my career.
This episode of Sounds Like Infrastructure was recorded using a sound desk, a computer, and an app that records high-quality audio from our tour guides. The script and editing were also done on a computer, and we shared the content online. These are everyday processes that we couldn't imagine working without. Digitalization is everywhere, including construction. Have you ever heard of BIM, Building Information Modeling? Jolie Downs, BIM modeler apprentice at Ferrovial Construction UK, is going to immerse us in the world of digitalization. She knows it from first-hand experience. She's learning all about this platform.
So, essentially, it's just a platform, and it's a way of incorporating different departments' information all in one place on one platform. So it can speed up the process across the whole construction life cycle, and enabling us to pull different parts of information just from this one platform.
This technological revolution might not seem like a big deal, but nothing could be further from the truth. It's remarkable how much BIM has changed how this type of work is done. It makes it possible to anticipate problems and helps prevent errors before construction has even started. It's like being able to make a miniature version of everything that's going to be built and envision what's to come. But it's not just that. BIM also helps to make projects much more sustainable, reducing costs, and making teams a lot more efficient. It is a constant, unstoppable evolution.
Although this technology is slowly expanding, it is useful for all types of projects, and at all budgets. Its increasing application over the next few years will be the revolution in engineering, architecture, and construction. We're already seeing its impact.
By creating models and sort of getting the different scenarios in place, you're able to see where issues could potentially arise or have arisen in the future, in the past, sorry. So sort of making sure you avoid those for future projects as well. I think at the moment, yes, it's used on sort of bigger infrastructure. However, I know with the BIM mandates they've got in place, they're looking to put it in all construction projects, and I think that would be very useful. Again, like I said, it will speed up the whole process, reduce costs, make things more sustainable. It also reduces the hard copy paper ones that we've been using. So all in all, I think it is a very good thing that needs to be implemented worldwide.
And if this wasn't enough, digitalizing processes will help make the world a better place. It will boost sustainability thanks to the use of less polluting technologies and a reduction of resources.
You can gauge different parts of the project life cycle along the way. So it's not a case of you get to the end point, you see the whole building model and see it as it is at the end point. You're able to see the different updates, and you can put it all in one place. So like I said, you're able to spot, like we've got clash detection. So if we're overlaying different drawings in the building, we're able to spot, okay, maybe this isn't right. So earlier on, instead of having everything put in place on the actual site and being like, okay, this beam clashes with this one, and then having to go back and redo that whole part of the construction. So in a case of sustainability there, yeah, and as well, like I said, not having to worry about hard paper copies and things like that.
What about the future?
I know that it definitely is going to continue progressing. Like day by day, I'm always learning new things. Like the other day I had used software, what was it, Power BI? And that enables the project managers, because at Heathrow, obviously, we have all the underground services that show where the lights will be for like the planes coming down on the runway. And obviously when doing works there, you have to turn off certain ones to do the construction works. So as that's being carried out, we've got that Power BI platform that will show which ones are being used, which ones are turned off, to make things safer and see, okay, can the planes land, or is it safe for them to do so? So going forward, there are going to be many more things like that are going to enable works, not just like at the runway with Heathrow, but on various different construction projects that are going to be able to spot issues earlier on.
Shall we keep going? Our last stop is Poland, specifically Warsaw West Station. It's one of the most important stations in Poland.
Can you imagine having to completely shut down the country's busiest train station for renovation? It would be total chaos. Well, when we face big problems, we need great solutions.
Well, the name is pretty self-explaining. You start building, it's only for subterranean structures, and you start at the ground level, and then you work your way down.
Starting with the roof may seem crazy, but it's actually what made it possible to carry out the redevelopment without having to close the station. Peter Maczynski is a section engineer at Budimex, and he was involved in the renovation of the station. He was born and raised in Warsaw, and thanks to his experience, we're going to discover what top-down construction is and why they chose this innovative solution.
To explain it like in a simple way, let's say the number of train tracks were divided into 4. So you divided the train station into 4 segments. You're doing one segment at a time. So you're turning off the train traffic on a single segment at a time, and then you have to rebuild it. That means removing the railway tracks, removing the old passageway, and building what's necessary of the new train station, then restoring the tracks and restoring railway traffic. If we would, thanks to this top-down technique, it takes about 6 months for each segment, I would say. But if we were to do it from bottom to the top, like the classic way, I guess it would take about a year more for each segment, at least.
Not many buildings are made this way. Warsaw West Station is one of the few examples in Europe, but the sheer number of passengers that travel through the station every day meant that the disruption to the trains had to be minimal. This top-down method allowed the team to close the tracks in sections. The station remained open with the work done in phases. This way, rail traffic was diverted to the rest of the tracks without any routes being stopped. It was an ingenious way of limiting the impact of the construction site.
If you need to be using the space at ground level, because it's like it's a place where you have, I don't know, vehicle traffic, train traffic, whatever, you can fairly quickly restore what was there before. The construction site is briefly at like ground level, and then you can remove the construction site and allow for operations, other type of operations.
The renovation was completed even quicker than if done in the traditional way, and the station didn't come to the standstill either. Throughout the work, Warsaw West remained the most important station in Poland. Passengers were barely impacted, and businesses were able to keep their doors open.
Innovative construction techniques were used to reduce the impact and to be more efficient. Evolution, evolution, and more evolution.
Thanks to David Azpiazu, Jofre Obrador, Jolie Downs, and Peter Matsinski for making this episode possible and for their part in the innovations in architecture, engineering, and construction.
Sounds Like Infrastructure is a collaboration between Ferrovial and Yes We Cast.
Our team includes Francisco Izuzquiza, Alberto Espinosa, Sergio Núñez, Luciano Branca, Fatima Gracia de Vargas, José Garcia Guaita, Arantxa Gulias, Claudia Castañón Piqueras, Bethany Ashcroft, Luis Trueba, and me, Kevin Garcia King.
If you want to hear more stories like this, listen to our other Sounds Like Infrastructure episodes or have a look at our blog. I'm Maria Ruano Najarro.
I'm Kevin Garcia King, and this is
Sounds Like Infrastructure.